Hello everyone. I'm going to now record the LRDI section of slot 3 CAT 2024. To just give you a preview, I think this particular CAT with the LRDI has been one of the easier ones of the past 3 to 4 years. And there's a slight difference in the pattern. We had 5 sets, 2 of them having 5 questions each, and 3 of them having 4 questions. That was not the case last year and a couple of years post-COVID. In terms of level of difficulty, I think there were far more doable questions in this particular CAT compared to the previous CATs. And let's kind of look at all the sets and then try to solve them as a part of this session. Okay. This set, the first set, it was one of the sets where I remember one of my students coming back and saying, "Sir, I solved it. I couldn't believe it was so easy. So I had to go back and see whether they are missing something." So there were a couple of sets like this. And we always see that there's one set in CAT that's a little easy. Okay. So question says, over the top OTT subscribers of a platform are segregated into 3 categories: kid, elder, and others. Some of the subscribers use one app and the others use multiple apps to access the platform. The figure below shows the percentage of total number of subscribers in 2023 and 2024 who belong to the kid and elder categories. So what do we have on the x-axis? Kid, elder, and then this is 2023, 2024. And on the y-axis, we have percentage of total subscribers. Okay, so whatever we have here is a percentage of the total subscribers. The following additional facts are known about the number of subscribers. The total number of subscribers increased by 10% from 2023 to 2024. In 2024, half of the subscribers were from the kid category, 2/3 from the elder category, and using one app. In 2023, the number of subscribers from kid category who used multiple apps was the same as the number of subscribers from the elder category who used one app. 10,000 subscribers from the kid category used one app, and 15,000 from the elder category used one app in 2023. Excellent. So let me do it for 2023 out here. So we have kids, elders, others. So let me put one app out here. Maybe I just and multiple app out here. So let me repeat this for 2024. Kids, elders, others. One app, multiple app. Okay. So what do we have here? First data. So let me pull these data out. Kid is 15%. So remember this 15% is percentage of the total subscribers in 2023. Elders is 20% in 2023. So the rest of them must be 65%. And then in 2024, we have kids is 20%. Elders is 30%. So the others must be 50%. Okay. Now let's look at each one of this. The total number of subscribers increased by 10% from 2023 to. So basically we are saying this increase is 10%. This is the total subscription. 2024, half of the subscribers from the kid category and 2/3 of subscribers from the elder category used one app. So half of these people, so this will be 10% of the total subscribers. This is 2/3, this is 20% of the total subscribers. from the elder category. So this is the case. Okay. So we're taking case of condition 2 as well. In condition 3, it says in 2020, the number of subscribers from kid category who used multiple apps was same as the number of subscribers. So let's call this as X, same as subscribers who use one app. 10,000 subscribers from the kid category use one app. So this is 10K and this is 15K in 2023. So I think uh, now the question becomes simple. So if I know the value of X, I can fill up all the others. So um, the total number of kids, 10K plus X divided by X plus 15K, this ratio must be equal to 15% of the total subscribers by 20% of the total subscribers. So I'm knocking off all the percentage. I'm straight away writing it as 15 by 20. So this is 3 by 4. So cross multiply, you'll get 40K plus 4X is equal to 3X plus 45K. What do we get from this? We get the value of X is equal to 5K. So if I get X is equal to 5K, it means 15% of the total subscribers is equal to 15K, which implies the total number of subscribers must be equal to 100K. 15% is equal to 15K, 100% is equal to 100K. So this means this has to become 110K. I think the rest of the things will be, let's look at the question. How many subscribers belong to the others category in 2024? Others category in 2024 was 50%. 50% of 110K, the answer is 55,000. What percentage of subscribers in the kid category used multiple apps in 2023? What percentage of the kid category? 5K out of 15K. So that is 1/3. That is 33.33%. 5 by 15. What is the percentage increase in the number of subscribers in the elder category from 2023 to 2024? So this can actually be done by two methods. One is either, let's take the numbers. So this will be 20K and this will be 33K. So from here you can see that it is moving from 20K to 33K. That's an increase of 65%. So the correct answer should be this. The other option is we know that it is moving from 20% to 30%. That's a 50% increase in percentage terms. And the population is also going up by 10%. So you do successive increases formula, A plus B plus AB by 100. So that will also give you 65%. So, I mean, even before filling in the table, I could have solved this question. If there is somebody who was just scanning the questions, they could have solved the question number 3 without even filling up the tables. Okay. What could be the minimum percentage of subscribers who use multiple apps in 2024? So we want to minimize this multiple apps. So let's make this 0, right? In which case in 2024, so we are left with 10% out here, 10% out here, right? If I take this as 0, in which case all the, look at this scenario, right? In this scenario, we can see that number of people who are using multiple apps would be 20% of the total population. So the correct answer to this question is this. Very simple question. And trust me, one of my students comes back and says, sir, ये तो believably नहीं था कितना आसान है. CAT में CAT ऐसे भी दे सकता है. So in fact, the last few years of CAT, we have seen pretty tough questions. And though we keep saying that there'll be one set that is easy, people sometimes find it a little difficult to believe that it could have been as easy as this. Now let's look at the next set. This set was an interesting set, right? Needed a little bit of idea of numbers, but I think not a difficult one. I would say this is a moderate one. The table below shows the amount in grains of carbohydrates, proteins, fats, and other nutrients per 100 grams of nutrients in 7 food grains. And the food grain category is given, column is given, right? So, uh, so basically what does it mean? That each of these row must add up to 100 because this is like per 100 grams. So each of these rows out here, all the numbers must add up to 100 grams. Okay. Now let's look at what are the data that is given. The following facts are known. Both the pseudo cereals are higher amounts of carbohydrates as well as higher amounts of protein than millets. Okay. Both the cereals have higher amount of carbohydrate than pseudo cereals. So both of them out here are greater than 66. All the missing values of carbohydrates is multiples of 5. Excellent. All the missing values of protein, fat, and others are multiples of 4, which means in column, in these 3 columns, all the missing numbers must be non-zero multiples of 4. So which means cannot have 0, but it could be 4 or 8 or so on. P1 contain double the amount of protein that P3 contain. Okay, so M3 contains. So X is there. So this must be equal to 2X. Okay. So let me first look at this and saying that, okay, these two, C1 and C2, they have to be multiples of 5, right? Because the column, carbohydrate column is all multiples of 5. So let's see whether we can fill up these. So if this has to be a multiple of 5, this is an even number. This is an even number. This also will be an even number. So this also has to be an even number and it has to be greater than 66. So what if I take the value as 70? If you take this as 70, this will end up becoming 18, which is not a multiple of 4. So 70 cannot be there. So the next even multiple will be 80. If this is 80, 80 plus 12, that is 92. So the value out here should be equal to 8. So we have fixed one value, one row. Let me, okay. Then let's look at to C2. C2, you see that this is an odd number, right? This is going to be an even number. So this has to be an odd number. So if the first column is an odd number, so the first, and we know that that value will be greater than 66, the first odd multiple of 75 of 5 that I can check out is 75. So let me check out with 75. If I put 75 here, 75 plus 3 is 78, 88, and this becomes 12. Now, is there any other possibility? The next odd value that I can go to is 85. In which case this value becomes 2. So which is not a multiple of 4. So we will kind of ignore this. So what do we have? The second row is also complete. Now let me go to the third row. Okay, we'll come to the third later because I want to fill the carbohydrate column first. Okay. Now this value has to be less than 66. So let me check what with 65. Because I need to check odd multiples again because this is odd and this is going to be even. So I must have odd multiples. I would check 65, 55, so on. So if it is 65, then 65 plus 7 is 72. And then 16 is 88. So this becomes 12. Now, if I go to 55, this must become 22 because this drops by 10. So this has to go up by 10. But if this becomes 22, it violates the case that it is greater than 14 because you see both the pseudo, so the first condition says higher amount of carbohydrates as well as higher amount of protein than any millet for pseudo cereal. So it is not possible that we can have 22 out here. So the only possibility for third row is 65 for carbohydrates, M2. Now, let's come to this, right? This is a multiple of 4. So this has to be a multiple of 8. So what are the values that I could have? 8, I could have 16. I cannot go beyond this because then this exceeds 100. So if this is 8, uh, 8 also I should skip because millet is 12. So I won't even bother to find out for 8 because this value has to be more than 12. So if that is the case, so this will become 16. 66 plus 16 is 82 plus 10 is 92. So this has to be equal to 8. There's only one value possible because the next value would be 24. But if I get to 24, then fat will become 0. But that will violate the case that this has to be a non-zero multiple of 4. So 16 is the only possible value in this case. If this becomes 16, the one on top will become 8. 8, 16. Let me also clean this up. This will be 12. Okay. Once this is done, we have 56 plus 8, that is 64, 76. So this has to be equal to 24. Now, what about these two values? These two values must add up and give me 28 because these two are adding up to 72. The other two must add up. And since there is no condition on millets, I could say this will be 4, 24, 8, 20, right? This will go on till 24 and this will go on till 4. So this is the data that we have. Now let's look at the questions. How many food grains add a higher amount of carbohydrate per 100 grams of nutrient than M1? So M1 is 62. We've got 1, 2, 3, 4. Oh, I didn't fill up this. So P2 will be what? P2 has to be more than 65 and less than 75. So there's only one option. This becomes 84 plus 8. And so this also becomes equal to 8. So 1, 2, 3. Then we have 4 and 5. So the answer to this question is 5. How many grams of proteins were there in 100 grams of nutrients in M2? M2, how many grams? So that answer is straight away 12. How many grams of other nutrients were there in 100 grams of nutrients in M3? M3 other, that is 24. So what is the median of the number of grams of protein in 100 grams of nutrients among these foods? So I hope you understand what a median is. So if I were to look at the median of this, I will arrange all these numbers in the protein column in ascending or descending order and then find out what is the middle value. So if I put them in ascending order, I'll get 8, 8, 10, 12, 12. Then we have 14 and 16. So which is the middle value out here? 12. Hence the answer should be 12. That's it. This is set 2. The reason why some of the students were able to attempt 4+ sets this year was almost all the sets were moderate. None of them really difficult. Right? And if there was one that was people thought was difficult in the exam situation, it is this one, because comprehending this for many people was not too easy. So let's look at this set. The AC in a room, large room, can be operated either in a regular mode or in a power mode to reduce the temperature. So you can either get into regular or power mode. If the AC operates in regular mode, it brings down the temperature inside the room, called the inside temperature, at a constant rate to the set temperature in 1 hour. If it operates in the power mode, this is achieved in 30 minutes. Excellent. The AC is switched off, the inside temperature rises at a constant rate to reach the temperature outside at the time of switching off in 1 hour. This is a very important thing. The temperature outside has been falling at a constant rate from 7 p.m. until 3 a.m. on a particular night. The following graph shows the inside temperature between 11 p.m. and 2 a.m. that night. The following facts are known about the AC operation that night. The AC was turned on for the first time. It was turned on first time at 11 p.m. The AC setting was changed, including turning it off or or setting different temperatures only at beginning of the hour and end of the hour, or at 30 minutes after the hour. The AC was used in power mode for longer duration than in regular mode during the right. Okay, so when was the AC on? AC was on in this stretch. It must have been on in this particular stretch, and it was on this stretch because the temperature is dropping. So now out of 2 hours AC operation, 2 hours AC was operating, right? So let's say it was switched on here, it was switched on here. Okay. Obviously it was switched off here, it was switched off here. We don't know about this, right? We're just taking the data till 2 o'clock, so we don't know what happened here, on or off or continuing to be there. Now, so if the total duration when the AC was on was actually 2 hours, right? Because this is 11 to 12 o'clock, then we have 12:30 to 1 o'clock, and then you have 1:30 to 2 o'clock. So that's a 2 hours. In these 2 hours, if the power mode was for a longer duration than for regular mode, it can happen only under one condition, that this part of it was regular. You set the temperature at 26 and it was supposed to become 26 in 1 hour. And right in the middle, half an hour later, you kind of shift from regular to power mode. So this was a power mode. This is power mode. This is power mode. That's the only way power mode can be 1.5 hours and regular can be 30 minutes. So power mode is the AC is operated on power mode for a longer duration than regular mode. Okay. Remember, this is because the AC is getting adjusted, right? After every 30 minutes, at best after every 30 minutes. So if at all there is changes, it could have made a maximum of 4 changes, out of which 3 of them have to be power and one of them has to be for the regular mode. So this is what happened. So here you adjusted mode from regular to power. In all the other cases, you are switching on or switching off. Excellent. Now having understood this, let's go look at the questions. How many times the AC must have been turned off between 11:01 and 1:59? Between 11:01 and 1:59. So obviously it was turned off twice. Once out here and once out here. So the answer to this question should be 2. What was the temperature outside in degrees Celsius at 1 a.m.? At 1 a.m., the AC was switched off, right? And we see that in the next half an hour, the temperature has increased by 4 degrees centigrade. So in half an hour, the temperature increased by 4 degrees centigrade, and the temperature is increasing as a constant rate, which means had you let it on, it would have gone till about, in the next half an hour, it would have gone till 4 degrees more. So it would have reached 34 degrees. Now remember, the AC reaches the outside temperature in exactly 1 hour time. Outside temperature at which point? At the point where when the AC was switched off. So at this time, the temperature should have been 34 degrees centigrade. So at 1, the temperature is 34. Now, actually, having got 2 points, it should be easy because at this stage, the temperature should have been 38 degrees. So at 11, it is 38. At 1, it is 34. And since this is happening at a constant speed, at 12, it should have been 36. At 10, it would have been 40. and at 9 it should have been 42 degrees centigrade. So what was the temperature outside at 9 a.m.? Temperature should have been 42 degrees centigrade. Looks like it was summers in Delhi. What best can be concluded about the number of times the AC must have been either turned on or the AC temperature setting been altered between 11:01 and 1:59? So what happened? This was once, this was second time, this is the third time. So the answer to this question is exactly 3 times. What is the maximum temperature difference between the outside and inside temperature between 11:01 and 1:59? So the first point where I would check is I will check what was the temperature, outside temperature here. So I can see that in a half an hour duration, the temperature has gone up by 4 degrees. Sorry, 5 degrees, right? Which implies in the next half an hour, it would go up till 36 degrees, 5 more degrees, which means at this point, the temperature should have been 36 degrees centigrade. So what is the difference? The difference is 10 degrees centigrade, and that looks like the highest difference across. So if you look at this at 1 a.m., we already found this is 34 degrees. So this difference is only 8 degrees, right? And I don't think there is anything here which is lesser than this. So the answer to this question has to be simply 10 degrees centigrade. So this question was not attempted by many because I think this looked a little new in the sense that interpreting the graph. So the entire thing was not about too much of logical manipulation of the data. It is pure interpretation of graph. Right? And a lot of people who are non-science students, I think they shied away from solving this. Right? I think even engineers, very few engineers did it. But I think graphical illustrations is there more in for science and engineers. They should have found it a little easier than the non-engineer student. Okay. Now let's go to the next set. This set was again I would say, fairly moderate one. Little bit of play with numbers, but not a very difficult one to do. The figure below shows a network with 3 parallel roads represented by horizontal lines RA, RB, and RC, and another 3 parallel roads V1, V2, and V3. The figure also shows the distance between 2 adjacent intersections. So this is the distance between these adjacent intersections. And since these are parallel roads, this will also be 4, 4, 7, 7, right? 5, 3, 3, 5, 5, right? I mean, this is just to understand. So I would kind of rub this off. Each ATM, 6 ATMs are placed in 6 of the 9 intersections. Okay, there are 6 ATMs, and since there are 9 intersection points, out of this, there are 6 of them are there's a installed. I mean, ATMs are installed in 6 of them. Each ATM has a distinct integer cache, which means all the numbers that we have as cache has to be different. And the numbers at the end of each line indicates the total cache requirement of all the ATMs placed in the corresponding road. Okay, 22 will be the ATMs along RA, 20 will be the sum of all the values on RB, so on. Okay. The following additional information, the ATMs with minimum and maximum cache are 7. So minimum is 7 lakhs and max is 15 lakhs. Okay. The distance between ATM with the second highest cache and the ATM with located at RC and V3. So we are talking about this ATM is 12 kilometers. For it to have 12 kilometers, the only possibility that I can see is 5 and 7, right? None of the other combinations are possible, right? So the second highest ATM has to be here. So there are 2 ATMs out here. Okay. Now, what are the various possibilities that I have? So, if I were to first think about the maximum value, can the maximum be here? If the maximum is here, the others have to become 0 and 0. right? I know that the maximum minimum have to be on this line, right? So let me tell you the logic of this. The maximum and the minimum have to be in this line because anyway they are in the same line, on the same road. So they can be on RA, RB, RC, or V1, V2, V3. So let me start with RA. So 15 plus 7, it looks obvious. It is possible to have both of them on this. 15 plus 7 cannot be on this road. 15 plus 7 cannot be on this road. Similarly, if I put V1, both of them cannot be here. V2, both of them cannot be here because they add up to 21. V3, maybe there it's possible that both of them are here. But if it was 15 and 7, the third one would have been 4. So in which case, you say that they cannot be, both of them cannot be on V3, V2, V1. Neither can both of them be on RB, RC, and RC, which means RA must have both of them. So having fixed that 15 and 7 are on this road, so let me try to look at where 15 could be. So let me start with 15. If 15 was in the first junction, right? These two junctions must be 0 and 0. Okay. Now, can I have 7 here? If you have 7 here, it means this will be equal to 14. And if this is 14, the other ATM on the road RB has to be 6, which violates the condition that 7 is the minimum. So 7 cannot be here. So which means 7 has to be here. So 7 is, so this ATM must have 7. If this is 7, right? So to add up 7 plus, if there were only 2 ATMs, it's not possible for us to have, because then this becomes 19. That's not the possible. So all the 3 ATMs must be in this. So in this condition, you have, okay. Now, so this is 0 and 0. So if this is 0 and 0, okay, this has to be 0. Now, what are the cases that we have in the, so this must be equal to 7 plus 8 plus 11 is one possibility. 7 plus 9 plus, that is 16, and 10 is one possibility, right? And there's no other possibility here. Okay, suppose I put 8 here. Let me see whether it works. If it is 8 here, then this will be equal to 11, and this becomes 12, and this becomes 9. Beautifully sitting in, right? So this is definitely one of the possible cases. What if this was 9? If this was 9, this would become 10, in which case this also should become 10, but that will violate the condition that we have distinct cache. So it cannot be 9. So let me knock this off. Okay. Now let me look at what if this was 11. If this was 11, this should become 9. And this anyway will become 8. If this becomes 8, this becomes 12. So it violates the condition that the second highest is at this place. So it's not possible. So 11 is not possible. And if 11 is not possible, then 12 will also be, 10 will. So let's look at uh, the case with 10. If 10 is here, it means the other one should also be 10. So the distinct cases will get violated. So it cannot be the answer. So the only option in this case where 15 is here has to be 15 0 0 0 12 9 7 8 11. Achha. Now what is the other case? 15 is not at this location. 15 is at some other location, and that location obviously has to be, it has to be here 15. Why is that so? If 15 was out here, the other number, the other number would have been 6, right? On this road, which is not possible, right? I mean, it is less than the minimum, but we have the second highest on this particular column. So it cannot be 15 there. So 15 has to be necessarily here. Okay. And we have already found that 7 cannot be here. So 7 has to be here. 7, 15. This is 22. Okay. Now, if 7 is here, okay, if 15 is here, we know that there is a ATM out here. That ATM has to be 11. Why is it? Because if there were two ATMs on this column, the average would have been 5.5. One of them should have been less than 5.5, other should be more than 5.5. But that's not the case because the minimum itself is 7, which implies there must be only one ATM here. Okay, so this is 20. So if this is 20, so this is taken care of. We need to have 20 here. So this is 0. Now, these two must add up. These two must add up and give you 20. So I can say that if this has to be equal to 15, this must necessarily be equal to 8. If this is equal to 8, this has to be equal to 12. Right? If this is 12 and I need 21 out here, this becomes 9. Now I can see that all my conditions are getting satisfied. The 20 is getting satisfied, this 20, and all these values of 26. So this is the other possibility that we can have. So this has to be equal to 0. 0 out here. Because 15 can take only two positions, either this first position or the last position out here. There is no other possibilities that we will have. So this is done. Now let's go and look at it. Which of the following statements is correct? ATM placed at RC and V2 as a cash requirement of 8 lakhs. RC and V2 is not. That should be 9. The cash requirement of ATM placed at RC and V2 intersection cannot be uniquely identified. It can be uniquely identified because each time we have got only 9 lakhs. There is no ATM placed at RC and V2 intersection. Of course, there's an ATM. So obviously, I think you don't need to even check this. How many ATMs have cash requirement of 10 lakhs or more? So in this case, in this particular first case, I can see that the answer is 15, 12, and 11. So that there are 3 cases. Similarly, here also we have 11, 15, and 12. So there are 3 cases in both. So answer to this question is 3. Which of the following statements are definitely true? Each of RA, RB, RC has 2 ATMs. This is obviously we see it is true. Each of V1, V2, V3 has 2 ATMs. This is not the case because it's only in this case that we see that 3 of them, right? And you got 1 year and 3 year. So this case is not valid. Hence, your answer has to be only statement A. What best can be said about the road distance between the ATMs having the second highest and the second lowest cash requirement? Okay, so let's say second highest is out here. Second lowest for us is 8. So in this case, it is 7 kilometers. So here we have second highest is here. And so in this case, this is 4 kilometers. So my answer has to be 7 or 4. What is the number of ATMs whose locations and cash requirements can both be uniquely determined? So we can see that the 12 is fixed in both the cases. The 9 is fixed in both the cases. And the 11 is fixed in both the cases. All the others are changing their positions. So hence the answer to this question is 3. So little play with numbers, maybe a little more moderately difficult for those people in the tension if you're not able to do, but otherwise not by any stretch of imagination, not the level of CAT questions that we had seen in the past. Okay, the last set. This was one set which had a little more calculations, right? Though the calculations are not very heavy, but somebody could think that this had more calculations. Out of the 10 countries, country 1 through country 10, country 9 had the highest GDP. and country 10 had the highest GDP per capita. GDP per capita is defined as GDP of a country divided by population. So GDP per capita, right, is nothing but GDP by population. The table below gives the following data about country 1 through country 8 for the year 2024. So this is for 2024. Column 1 gives the identity, column 2 gives GDP. Okay, all these are very clear, right? I think the titles are clear, so I don't have to bother to read about this. But what I need to do is column 2 gives the GDP with respect to country 9. So country 9 has the highest. So we are always comparing with respect to country 9, and GDP per capita, we are doing it with respect to country 10. So these are two. So if I call this as some value X and this is value Y, right? You will see that it's not material, but in the calculations, I would like to show you, right? Assume that the GDP growth rates and population growth rates of country will remain constant for the next 3 years. So which means questions will be there till 2027. Now, so for example, to interpret this, what does the GDP of country 1 mean? Country 1 GDP will be equal to 0.15x. And GDP per capita of country 1 will be equal to 0.41y. This is what it means, right? So you'll have for all of them, all the others, it will be 0.14x, 13x, 12x, 0.1x, right? 0.08x, so on, right? So you kind of append this with x and this with y. Now let's look at the questions. Which one among the countries 1 through 8 has the smallest population in 2024? 2024, which has the smallest population. So how do I find out population? I have to divide GDP with GDP per capita. GDP by GDP per capita, right? Sorry, this is PC. This must give me the population, right? So let's find out for each one of them. Don't bother about the decimals. I will just check 15 by 41. So which are the countries that we have to check? Country 3, 5, 8, 7 and 8. Country 3 is 13 by 2. I'm just, see, 0.13x, 0.13x by 0.02y is same as 13 by 2. So that's why straight away writing 13 by 2. That was country 3. Then we had country 5, 10 by 36. Country 7, 8 by 30. And country 8 is 7 by 41. We want to know which of these has the smallest population. So look for the number that has got the smallest here. So the number that is smallest here outside is obviously this. And that is country 8. So the answer to this question is country 8. The ratio of country 4's GDP to country 5's GDP is closest to 4's GDP to 5's GDP. 4's GDP is 0.12. X in 2024. 5's GDP is 0.1x. So basically it is 12 by 10 into, let me find out what is the growth rate of GDP. So for country 4, it is GDP growth rate is 0.5%. So this is 1.005 squared, because we are looking at 2 years, whereas for GDP 5, it is 1.007 squared. I'm assuming that this value is approximately equal to 1, because I see the choices are fairly far apart. So what do we have here? We have 12 by 10, that is equal to 1.2, into a value that is less than 1, but approximately equal to 1. So my answer has to be very close to 1.2. I can see here that this is like very far away, very far away, very far away, right? So this has to be my answer, 1.195. So if you're looking at the maximum population, so for country one, I will just look at 15 by 41 into 0.999 cube, because the population is reducing by 0.12%. For country four, I would look at 12 by 38 into 1.005 cube, right? Um, and then we have um, country 5 is 10 by 36 into 1.0031 cube, and then country 7 is 8 by 30 into 0.00, I mean 999 approximately, right, cube. So if I were to compare this, I'll just compare these values because these values are almost close to 1. So I can see that in this, country 1 is definitely much more higher than any of the others. So I would mark country 1 as my answer to this question. For how many countries among country 1 through country 8 will the GDP per capita in 2027 be lower than that in 2021? So GDP per capita, right, has to be lower, which means, see, basically, what is it that GDP per GDP divided by GDP by population, right? That gives me GDP per capita. So if the GDP goes up, population comes down, GDP per capita must go up, right? So for example, if I were to look at this country 1, GDP is going up, population is coming down. So GDP per capita will go up in 2027 or whichever year, right? Subsequent years. So this is also going up, this is coming down, this will also go up. This is going up at a faster rate than this is going up. So the numerator is going to increase at a faster rate than the denominator, right? So you will see that this will go up. Again, this is going at a faster rate than this one, this will go up, right? All of them are going up because the GDP growth rate is faster than the population growth rate, or the GDP growth rate is positive, whereas the population growth rate is negative. So you will see that the answer to this question has to be 0. So that was the end of the recording for this particular set. And as I said, though when you look at each question, each set independently, right, you will see that दो तीन sets तो होने ही चाहिए, but in the exam, because of the pressure, I think many of the people were able to do two sets, but a small number did 3, and I think a very small minority actually ended up doing 4 or 5 sets.